Hey everyone, I'm Richard. In video 2 we successfully created our hair color panel using signals in a ColorPicker to dynamically change the character's hair color. Now in video 3 we're building the skin tone panel. Instead of a ColorPicker, we'll set up a global script to hold a list of predefined colors and then build custom buttons to let the player select their skin tone. So let's locate our global script from the resources we downloaded in video 1. If you don't have them, you can find a link to those resources in the description below. Make sure to have the root res folder selected and then drag your global script from the resources folder into the file system panel. Open the global script and you'll see it contains a skin tones dictionary with multiple color names and the respective color values. Let's make them available globally. In Godot we do this with the AutoLoad feature. Open the project settings. Switch to the globals tabs and we should find ourselves in the AutoLoad section. Click the folder icon next to path and then select and open global.gd. The name field should default to global. This is the name we'll use to access this data from any script in our project. Add it and now we should be able to start building. For the interface design, we'll follow the same layout pattern as the hair color panel. Open the main scene. Inside the left container, create a new panel container and name it SkinTonePanel. On the right, in the theme override style section, load the panel style we created in the previous video. This immediately applies the dark gray background, border, and inner spacing as it did for the hair color panel. Right-click on the skin tone panel and create a VBoxContainer. In the constants within the theme overrides, set its separation to 15 for spacing between the inner nodes. Inside the VBoxContainer, create a label. Give it the text skin tone, change its horizontal align to center, and set the font size to 25. Finally, let's add the last child node to the VBoxContainer, a GridContainer. Set its columns property to 5 to create a 5-column grid for our buttons. Set both separation values in the theme overrides constants to 0. Now in our file system panel, create a new folder inside interface and call it SkinTonePanel. Then save our SkinTonePanel node as a new scene inside it. Our skin tone swatches will be custom buttons. Since we'll have specific logic for them, we'll make the button a reusable scene as well. So let's also create a new folder called SkinToneButton inside SkinTonePanel. Then create a new scene inside it, using a button as a root node. Select the SkinToneButton node and for the custom minimum size, set both the X and Y values to 60. Inside the button node, create a margin container. Set its layer preset to full rect so it occupies the parent node space. And then in theme overrides, set all its margins to 5 pixels. Inside the margin container, create a ColorRect. This is the node we will use to display the actual skin tone color. Now, select the SkinToneButton node and add a new script called SkinToneButton. Define the class name as SkinToneButton and add a public variable to hold the key for the skin tone. And then we reference the ColorRect node with the onReady keyword, declaring an underscore ColorRect variable and using $sign to specify its path in the scene. In Ready, we'll use the skin tone key to pull the corresponding color from our global script and use it to set the ColorRect's color. Let's now open the skin tone panel scene and be sure to have the root node selected. Then create a new script for it called SkinTonePanel. Define the class name SkinTonePanel and create a custom signal called changed, which when emitted, should send the skin tone that was selected. Declare the reference to the GridContainer the same way we did for ColorRect before. Then create a SkinToneButton scene variable to which we will preload the SkinToneButton scene, so we can create many instances of it later. Instead of manually typing the path to that scene, we can just drag it from the file system. Let's create another variable and call it SkinToneButtons. This one will be a dictionary of type string and SkinToneButton. We're giving it these types because we are planning to use the skin name keys and associate each one of them to their corresponding button. Now we will initialize it as empty and we will create a function to fill it with data soon. Lastly, we also want to keep track of which skin tone is currently selected. So let's create a variable for that too, called currentSkinTone. Inside our ready function, we will create our buttons. But instead of doing it directly inside, let's call to a function called createButtons, and we'll create that function underneath. The first thing we will need is all the names of the skin tones, so let's get the keys from our global script SkinTones dictionary. And if we open our global script quickly, we can have a look at what we will be getting, which will be a list containing each of the skin tone names on the left side of the dictionary. Let's head back to our createButtons function, and then for each skin tone in that list, we'll create a SkinToneButton by instantiating our preloaded scene. Then we are telling the button which skin tone it should paint for itself in the grid. And we also need to know when the button is pressed, so we connect to the button's built-in press signal and we want to call our onSkinToneButtonPress function, which is not yet defined. Notice we're binding the specific skin tone key to the function, so when a button is pressed, the function knows which skin tone was selected. Now we need to add the button to the GridContainer so it becomes part of the panel. And lastly, we save a reference to the button by using the dictionary we created before, using the skin tone as a key and the button as a value. Let's create the onSkinToneButtonPress function so we can finish the panel's logic. We will receive the skin tone as a parameter and we want to save that value as current skin tone, and also inform of this new skin tone to all functions connected to our change signal. Save and open the player script. Just like we did with the hair color, let's create a public function called changeSkinTone, which will receive the skin tone key and through the global skin tone constants change the modulated color of both our head and body sprites to tint them to that color. Time to connect everything together. Go to the main scene and then open its script. Then create a reference to the skin tone panel the same way we've been doing so far. On the ready function, connect our custom change signal and pass the onSkinTone function which we want to have trigger when the panel emits the signal. Now let's define that function below, receiving the skin tone from the panel, and then we call the player's changeSkinTone function we just created before, passing that same skin tone. We should be good to go, so let's check if everything is working. Run the project. You should see our grid correctly filled with colorful buttons, but if you click on them, nothing really happens. The issue is subtle. Let's open the SkinToneButton scene and switch to the 2D view. Then select the ColorRect node, which is our culprit. This node is intercepting the mouse click, preventing the button node from registering the pressed event. So in the inspector, under the mouse section, change filter from stop to ignore. This tells the ColorRect to let mouse events pass through to its parent, the button. Hit play again. Now when you click on any of the color swatches, you'll see your character's skin tone instantly change. We've successfully created a fully functional skin tone selector. In video 4, we'll start tackling the most exciting part, implementing the functionality to swap armors and weapons. Thanks for watching, and I'll see you in the next one.